Hi, I'm Peter. In this video, I'll explain the difference between three popular types of network devices: hubs, switches, and routers. Let's start with a hub. Hubs are cheap and simple devices that can connect a bunch of computers to each other, but they're a little wasteful with bandwidth. Here's how they work. When a computer sends information to a hub, it replicates the data on all other interfaces. It works like this. Bit comes in, clones come out. Bit comes in, clones come out. You get the general idea. A hub doesn't know anything about packets, and it doesn't bother figuring out who is supposed to receive the data. No, it just spams everyone. The receiver will get the message, and the other hosts will ignore packets if the receiver field doesn't match their own address. Not bad for a glorified bit cloning machine. Alright, so every incoming bit is replicated on all other interfaces. That's a fairly simple and cheap way to create a network. However, it does cause a lot of unnecessary traffic. If you have 5 hosts in your network, hubs unnecessarily send every packet to 3 hosts that aren't interested. That's a huge waste of bandwidth. Also, keep in mind that other people in the network can see your traffic if they use free software like Wireshark. If you're embarrassed about your addiction to funny cat videos, maybe hubs aren't your best choice. Now wait a minute, there's a better way to do this. If our hub kept a list of where every host can be reached, then it would be able to send every packet straight to its destination without spamming the entire network. That's what switches do. In this example, we've plugged in computer A to port 1 and computer B to port 6. Each network card has a unique address that switches can use to identify a computer. They're called MAC addresses. They're not only used for Ethernet connections, Wi-Fi uses it too. If computer A has a MAC address of 6 times AA, then the switch will know that the computer with that MAC address can be reached on interface 1. In addition, we know that computer B, which has a MAC address of 6 times BB, can be found on interface 6. All this information will go into the switch table. Now, for this example, I will add 2 more computers. Computer C is hooked up to port 3 and computer D is hooked up to port 4. We have our network now. Let's see how it works in practice. We always start with an empty switch table because the switch has to learn where everything is. And in this example, we will send a packet from computer A to computer C. At this point, the switch does not know where C is, so it will just behave like a hub and flood everything. But it's learning. By checking the MAC address in the packet's sender field, it learns that computer A can be found on port 1. It will store this information in its switch table. Now watch what happens when we send a packet from computer C to computer A. Since the switch knows that computer A can be reached on port 1, it doesn't have to flood the entire network. It only has to send the packet to port 1. The switch now knows where computer C is and adds a new entry to its switch table. Hubs and switches are devices that can be used to create networks, but what if we want to send packets between those networks? That's where routers come in. Say you want to send a packet to your search engine from your home laptop. Once you send your packet to the internet, how does it find its way to the search engine server? That's the work of routers. Once you send the packet to your internet provider, routers make sure that your packet is passed on from network to network so that it eventually reaches its destination. If all goes well, that is. You probably have your own router at home too. It forms a bridge between your own private network and the network of your internet provider. Through the network of your internet provider, you can reach the rest of the internet. Modern routers also carry out other tasks. For example, they often do network address translation, or they can hand out IP addresses to hosts using DHCP. We have videos on both of those topics, so just click the thumbnails if you want to watch them. Additionally, many routers can also act as an access point for Wi-Fi. Now that we've gone over all 3 devices, let's compare them. It is worth pointing out that hubs, switches, and routers each operate on a different layer. You may recall from other videos that every packet traveling over the internet consists of 5 layers. The physical layer is just raw ones and zeros. Since hubs just replicate bits, they operate on the physical layer. The link layer is specific to the medium over which the packet is traveling, such as Ethernet. MAC addresses are part of this layer. Since switches rely on MAC addresses to get packets to the right destination, they operate on the link layer. The network layer is where the IP protocol does its job. A packet's source and destination IP addresses are stored here, among other things. Since routers work with IP addresses, they operate on the network layer. Right, so when should you buy a hub? Generally speaking, don't waste your money on them. As we've discussed, they're huge bandwidth wasters, and although it used to be that switches were a little more expensive than hubs, that's no longer the case. So if you're gonna buy a hub, just buy a switch. There are some special use cases for hubs though. For example, they can be used to tap internet traffic for analysis. The main advantage of switches over routers is that they're cheaper. If you need to connect to other networks, you can still connect the uplink port of your switch to a router. In fact, you can connect multiple switches to the same router to save money. Switches are less complex than routers, so they can handle traffic faster than routers can. This is great if you want to minimize latency, perhaps during a LAN party with your friends. However, routers often have a built-in Ethernet switch to handle internal traffic, so switches aren't necessarily faster. The main purpose of routers is to connect networks to one another. Routers often support network address translation, which is necessary if you want to give computers with a private IP address access to the internet. Unlike your average switch, routers often have a DHCP server on board. Thanks to DHCP, you don't have to manually configure IP addresses for all hosts in your network. Well, I seem to be out of slides again, so I guess I'm gonna stop talking in a few seconds. If there's anything you'd like to see explained on this channel, drop your suggestions in the comments, or, ask your local carrier pigeon. He'll know where to find me. Thanks for watching, see you next time.